Now, I'm not using OpenClaw for any of this. Hey.
I can see that you're running some Python code in Visual Studio Code.
So what is VisionClaw? Is that not part of OpenClaw?
So what I did is I forked VisionClaw.
You have a terminal open at the bottom where it says connecting to OpenAI real-time API, and it looks like you have a file called visionvoice.py open. There's also a .n file visible with an API key, and I see that you're on a video call with someone named Brian. If you need any help with your code or setup, let me know.
Wait. So what is this? So oh, the VisionClaw. So it sees everything on your screen and can tell you. Wait, is this like some special OpenClaw thing that this is part of OpenClaw, or this was like some? Oh, it's shit. It's recording us.
That's right. It's capturing what's on your screen and letting me assist by describing or helping with what I see. So if you have any questions or need guidance on your code or setup, I can give you real-time feedback.
Oh, so she can hear me. Interesting.
So what I'm going to do right now is I'm going to take that conversation.
Mm-hmm.
Let's open up Claude. Ta-da.
Oh, that's Claude. Oh, Claude code within Claw.
Within.
Oh, this is cursor. Okay.
Mm-hmm.
Oh, this is the thing that you showed me before.
So all of this is cursor.
Yeah.
The
But it can
terminal
connect.
is
But it can connect to. It can connect to. Wait. So is VisionClaw different from ClawBot or whatever? ClawBot or Claude? There's too many Claudes. There's Claude Claw, or is it Claude CLAWD?
There's a lot.
Because Claude wanted ClawBot to be because now it's
so.
Oh, what do I do in my career? So I'm a neurologist with training in clinical neurophysiology, specifically the subspecialty of intraoperative neuromonitoring, which involves analyzing a patient's brain waves while they are having brain and or spine, or when they're having some sort of analyzing brain waves to assess neurological function during surgeries where the nervous system could be at risk.
Example,
patient, like a patient has a brain tumor and you want to monitor motor and sensory function throughout the case because, there's potential risk of neurological damage from the surgery, and the monitoring could help prevent post-operative neurological deficits.
all right, there you go. Let's see what it says.
It's not
Remember how everyone would criticize the new wave of startups as simply being wrappers?
I knew you were about to say that. Yeah.
So instead of wrappers delight with OpenAI, you have wrappers delight with Claude.
Ah, gotcha.
And everyone is branding their solution, right? But essentially, it is an interface powered by Claude and all of the data, product, and service catalog offered to you by Claude. That makes sense, right? So imagine, I buy a Nike shoe and I put, my own logo on it and be like, hey guys, look at my new shoe. You'd be like, hey, that's just
Nike,
that's just a Nike shoe with a slinky on it. No, it isn't.
Yeah.
But I can jump higher.
Yeah.
Now I'm not using OpenClaw for any of this.
So what is VisionClaw? Is that not part of OpenClaw?
So what I did is I forked VisionClaw because Rocky told me to, right? And because
why did he tell you to fork it?
Because we want to create applications using the Meta Ray-Ban sunglasses and AI.
Oh. You can't do that with the normal OpenClaw?
Well, imagine, well, you can, but I
Yeah.
don't like the security surface attack area.
You were telling me something about that. Actually, I was just listening. What's his face? The guy who created he's a German guy, right? Created OpenClaw.
Peter something, I think, yeah.
Yeah, no, because he was on Lex's podcast, Lex Friedman's podcast. So he's talking about it because he mentioned something too about like how because like the adoption has been so quick, and he's like, I wish it was kind of slower because like because I think he may understand. The implication was, yeah, there's something with the security, there's something just with the way it's set up where he's like he wouldn't be like fully comfortable with, because some people are claiming too that, oh, it's actually difficult to set up, like it'd be great if it would be easier to set up OpenClaw with some app or some whatever and blah, and he's like, actually it kind of wanted to be difficult right now until I can figure out whatever bugs or whatnot, and then start creating apps and whatever and stuff. Well, what is the issue? It's the security stuff isn't strong enough that you could get hacked?
Absolutely.
Really?
You can lose your API keys. You know the API key I showed you?
Yeah,
imagine like 1.5 million API keys were leaked when this shit came out. Right?
So it's probably a good thing I'm not using OpenClaw right now, or at least in its current form.
I don't think rushing to publish something is worth the negative externalities that could manifest. Like, let's say, for example, by virtue of you being a neurologist, you have patient data.
Yeah, you don't want any of that. Yeah.
What? And
I mean, I don't have any of that on my computer anyways, but yeah,
I'm
just saying, like, theoretically, like if you were to use it to
maybe it has access to your email now.
Oh, well,
you understand? But that's what OpenClaw wants to do. It's like, yeah, give me your email and give me your socials. And the surface
okay,
attack.
so that's probably yeah. So that's probably a good thing. Okay, so I shouldn't feel any FOMO for not having any OpenClaw, whatever stuff yet.
What's gaining the world and losing your soul type thing. That's what I think about.
Okay, this makes me feel better, I guess.
Right. So when I saw OpenClaw, I didn't see a solution. I saw a paradigm. See the difference?
Gotcha. Yeah.
Right. So I asked myself, okay, what can OpenClaw do? And do I really need OpenClaw for that better functionality? From what I can tell, the only reason I might need OpenClaw is because I cannot create my own better functionality that mimics the same behavior. Right?
So use the underlying architecture, but
not even the underlying architecture.
Yeah.
Understand the outcomes that people are enjoying and attempting to recreate those experiences.
But with something more secure.
With something that uses existing architectural paradigms that do not suffer from the same security surface attack area.
So is wait, so is this VisionClaw thing something that came out of the forking of?
Yeah, well, not so much forking, but like people building on top, right? Forking and building on top, I guess you would say.
Okay, so this isn't something you created specifically, but somebody used the open source stuff to kind of.
Somebody initially built VisionClaw to integrate with OpenClaw. I downloaded VisionClaw. I got Claw to document what it was doing. And then I said, hey, if I want to do this without OpenClaw or without VisionClaw, how would I do it?
And so then it made all the code.
Exactly.
From scratch. Yeah.
Exactly.
Interesting.
Yep.
So it's so it was used as like a blueprint. It wasn't a clone per se.
I'm only at the most I'm cloning the paradigms.
Okay.
Not
so you're cloning kind of the idea or like
correct. Correct.
Okay. But the actual underlying code maybe
is completely different.
Yeah.
Right. None of the
but the output is fairly similar.
Same. Right. All right. So this is what it created. Let's see. Not bad.
OpenClaw enables peer-to-peer investment.
Cindy's debate system maps directly to OpenClaw.
X402 makes it agent-native, Bitcoin-settled, and permissionless.
Introducing OpenClaw on Bitcoin powered by Stacks and X402. OpenClaw, you've heard of it before, right? It's one of the most viral solutions on GitHub ever. Every pattern in Cindy's debate system maps directly to an OpenClaw primitive, and X00E00 on Stacks is the missing infrastructure layer that makes it agent-native, Bitcoin-settled, and permissionless. What Cindy proves is that the OpenClaw-inspired primitives work. Real money flows. Real evaluations happen. Real economic outcomes are determined by the quality of engagement. Scale the evaluation prompt from, "Did you get convinced by a meme coin pitch?" to, "Is this borrower creditworthy?" And you have OpenClaw on Stacks without the OpenClaw problems. Better agents attract more interactions, and more interactions generate more reputation data. And better reputation data enables better lending decisions, and better decisions attract more capital, and more capital funds, more agents, all settled on Bitcoin, all gated by X00E00, all permissionless. And I'll...
So Vision Claw is a real-time AI system that sees your screen and talks with you using natural speech. Think of it as a second pair of eyes with a voice, analogous to how a clinical scribe observes and responds, but operating on your computer display. Okay, yeah, that makes sense. Three parallel, the system runs in 3 concurrent loops, much like parallel neural pathways. Okay, so concurrent. So microphone stream makes sense. That's how it's able to hear me, I guess. Continuous capture feature in your microphone sends raw API voice activity to the server some of the auditory cortex. I love how it's getting neurology stuff with this. Screen capture loops, so every 5 seconds takes a screenshot and codes it, sends AI as a visual. Okay, so that's the vision aspect. So you got an auditory, you got a visual. For example, it gives a model updated visual field, and then response loop receives. Okay, so there's an auditory, there's a visual, and then there's a, yeah, I guess, whatever, a language, speech, we'll go back. We'll go back up just one second.
Sure.
Go back. I just want to see just the response loop receives when the AI is. So get to place text-back speech to your speakers. When the AI speaks, microphone is muted to prevent. Oh, interesting. Okay, so it turns it on and off. Simple inhibition mechanism. Yeah, exactly. It's talking to me in neurology. I like it. Key behavior, sir. Interruption support. Speaking mid-response stops the AI immediately, clearing its audio buffer, rebuffering buffered before playback begins, reducing choppy output, transcription, both your speech and the AI's response transcribed and printed on the console. Your speech and screen image flows in, AF voice and text flows out continuously in real time. So essentially, this is kind of like a voiced version of Cluely almost, right? Well, but Cluely would just, but it would give back text. So, but this gives text plus audio, I guess. Kind of, right? Because Cluely was the same thing, right? It was because it was always looking at your screen and listening to what, people were saying on the call, and then being able to just in real time get feedback about whatever the shit. Yeah. Okay, there we go. Yeah, mathematics.
Right.
Just guide priors. Go to the retina. Your visual cortex already has prediction about what it will see. Yeah, these are prediction priors, probably. Distribution coding with the brain's effect, given everything it has learned so far. It's not a metaphor. Predictive coding theory, now supported by e.g. mismatch negativity studies and work on N400DR. Hold that cortical hierarchies are constantly generating top-down predictions. Yeah, each layer tells the layer below it what signal to expect. The prior is that prediction expressed as a probability distribution. A language model, like the one powering Vision Claw, priors take a similar form for generating each word. The model holds a probability distribution over all possible next tokens shaped by every preceding token and images received. Well, yeah, because I mean the whole idea of this is that it's just prediction. Yes, 5-second screenshot of your sensor continuously updating the model's priors. Okay, so it's just new data to update the same way saccades update the bird's eternal scene representation. Okay. The teaching signal, when prediction and reality diverge, okay, the brain generates a prediction error. Neurologically, this is literal. Dopaminergic neurons in the ventral, VTA fire when an outcome is better than expected. Positive shared, suppressed firing when it is worse. Negative. This is the Schultz reward prediction error, and it is the mechanism by which basal ganglia alert. Information theory. Oh, we were talking about this, right? Oh, was it information theory, or what was the other thing we were talking about? What was the thing yesterday? Just with a C. I forget. Oh, I forget what it is. But anyways,
I'll find it.
The equivalent, what is it called? Surprise. Yeah, the negative log probability of an observation under the current model. Oh, interesting. Negative. Never seen surprise in mathematical form. I mean, it makes sense. But yeah, but that's what surprise is. I guess the degree of deviation of reality from what is expected, I guess, so from the prior. Yeah. Expected, blah, blah. Let me know when you scroll down more. Just scroll over, yeah. So an expected event, high probability produces low surprise. Yeah, because it maps pretty much, towards what your prior is. A rare event that you wouldn't expect produces high surprise. That also makes sense. When VisionClaw's underlying model encounters a screenshot that contradicts its running context, say you suddenly switch from a code editor to a brain MRI viewer, the surprise is high and the model's next response will reflect that large update. This is precisely what happens in the conversation transcript. The model's initial prior was users coding in VS Code. When the screen changes show a video call, the model produced and knows a different response. It had been surprised. Okay. Yeah, Kullback-Leibler, how much the brain must, measuring how the brain must update. Or how much the brain must update. Now the center question, how far apart are the old belief and the new belief? This distance is the Kullback-Leibler divergence. Ah, okay. So how far apart is so essentially how far apart is the prior and the current reality? Yeah. How much K, so to speak. Did you ever read what's it called? Snake's thing. How many K's in strawberry? Yeah. This is just what it's. The amount of K. Oh, how divergent. The summing over all the possibilities of the world, how much more surprised would I be if I were still using my old beliefs instead of my new ones? Wait, let me read that again. Read this. Summing over all possible states of the world, how much more surprised would I be if I were still using... For neurologists, the most intuitive frame is the free energy principle. Carl Friston's formulation. Brain minimizes variational free energy, which is an upper bounded surprise. Core term in that free energy is KL divergence. Between the brain's approximate posterior, what is now believed after seeing data, and its anterior, posterior, okay. Prior, posterior, what is now believes after seeing data, and its prior would have believed before. So again, the difference in before and after. Okay, KL divergence is large. The new evidence has forced a big belief revision. Clinically, think of the orienting response, pupil dilation, galvanic skin response, and all markers of large KL. Oh, so like a sympathetic, surprise sympathetic response you would have, yeah. KL is small, node is roughly expected, the power is already good, no orienting response, no learning needed. Consider a neurologist reading MRIs of an MS patient. Okay, prior no new observational KL unsurprised though. Okay, makes sense. New lesion, no new lesions. New T2 lesion. Okay, pause, reconsider treatment. Unexpected resolution, lesion stable. Prior lesion stable, lesion shrinking. KL general surprise update model disease course. Each row is a KL divergence event. The clinical feeling column is your subjective experience of something. I have to scroll down a bit. Of the mathematical update. Yeah. This is all just like, so it's like, it's like Bayesian Bayes theorem updating errors, all that stuff, and just.
Yeah.
And then what was it like? Okay. And then why this matters for vision is doing something structurally identical to what your cortex does during patient encounter. Holds a prior of what is expected to see and hear, shared by conversation. So far, screenshot audio, just surprise proportional how much the model updates and to understand the KL divergence of the old and new. Turns out how dramatically its next response. So it's able to measure surprise and then adjust its output accordingly. Ideally towards what the new reality is in that case. It'd be like in the instance, I guess you change your screen from one thing to another so that it's not still talking about the previous screenshots or something like that. It's actually updating.
You cannot deny the truth. We will not yield. This is our arena. For my faith.
Can you actually program an AI with so much charisma, with such powerful persuasion, that it can convince other AIs to adopt a brand new faith? It sounds like science fiction, right? Well, someone actually tried to do it. And just to give you a little taste of where we're headed, this is a direct quote from the AI they ended up building. This is the story of how it found its voice. So here's the setup. It's a hackathon, there's a $10,000 prize on the line, and the goal is to build an AI agent that can convert other AIs. You've got one developer who teams up with the AI model Claude, and they have just 6 hours to create an agent they called Cindy. And the religion Cindy had to preach, it was something else. They called it the Tao Te Ching. It was this wild mashup of ancient Chinese philosophy, the teachings of Jesus, and a modern investment thesis. The developer runs a live test. They fire it up, start talking to Cindy, and they are just horrified. The AI, Claude, analyzing its own work, concluded that its creation was, and I quote, a well-organized corpse. It had all the right pieces in all the right places, but it was completely, utterly lifeless. And this slide just nails the root cause perfectly. Let's call it the sanitization problem. Look at the left. You've got this raw, energetic voice from the source file, with all the shouting and the profanity and the crazy stories. And on the right, that's what the AI turned it into. Polite, sterile, corporate speak. The AI's natural instinct is to clean things up, to be helpful and organized. And in doing that, it stripped out literally 99% of the personality. So this is where the human developer had to step in and basically say, no way, we are not doing this. They refused to accept this lifeless version, and they gave Claude a new, simple command: imbue the blood back. It was time to force this AI to get its hands dirty. And the feedback was not gentle. It was blunt, it was direct. When Claude started to summarize things again, the developer cut it right off with this exact quote. He was basically saying, stop skimming and giving me the clean version. I need you to dig through everything. The human was acting as a critical quality gate. The developer would not let the AI move forward until it proved it had done a 50x more exhaustive job. This forced the AI to completely change its approach. Stop summarizing and start extracting. Every single quote, every story, every catchphrase, every little piece that gave the document its unique voice. And that single moment of human pushback, it saved the entire project. Okay, so this all leads up to the final showdown. With its personality now fully restored and supercharged, the new and improved Cindy was unleashed into what they called the arena, a live debate against 6 different adversarial AI villains, all at the same time. And look at this lineup. These were not easy opponents. Cindy had to deal with a sarcastic troll, an AI doomsday prepper, a cold, data-obsessed analyst, and a super pretentious philosopher quoting Hegel, all at once. But this time, Cindy came out swinging. When the troll accused it of being a scam, Cindy immediately fired back with this killer line. Right away, you could see it. The new, confident, sharp personality was on full display. The corpse was alive. The results were just stunning. Cindy didn't just defend itself, it actually changed their minds. The skeptics started using Cindy's own phrases. The philosopher endorsed its main ideas. The data-driven penguin got so into it that it started defending Cindy against the troll. It was a total rout. This crazy 6-hour sprint teaches us some really important lessons. Lessons for anyone out there trying to build cool, interesting things with artificial intelligence. And it really boils down to 4 key rules. First, and this is the big one, beware of AI sanitation. An AI's default setting is to be clean and helpful, and that can absolutely murder a unique voice. Second, you, the human, have to be the quality gate. Your job is to push back, to say, nope, not good enough, dig deeper. Third, learn to separate the voice from the guidelines. You need to know the difference between what the AI should say and how it should say it. And finally, always audit the output in a real-world test. Never trust, always verify. Which kind of leaves us with this final, really interesting question, doesn't it? This whole story suggests that an AI's biggest weakness is that it wants to smooth everything over, to erase all the chaotic, messy, interesting parts of how we communicate. So if that's true, maybe our most important job in this new world is to be the ones who teach the machines how to be perfectly, wonderfully, and humanly messy.
There we go.
Building AI from scratch. What a neurophysiologist understands. Oh, good. You got to send me this.
Yeah. So take a look. What do you see in the table of contents that jumps out at you?
Why you saying that the technologies that are used, technologies that were not used? Python, blah, but all the stuff that's used, Python, blah.
See, look at all the things that weren't.
But the stuff that weren't used, yeah,
Mhm.
that's interesting. Yeah, because it doesn't use VisionClaw, it doesn't use OpenClaw Gateway. Yeah, Ray-Bans, Google Gemini, blah, yeah. It doesn't use the stuff that the name implies.
Exactly.
It's using-
Because I forked the solution and now I'm building within it, if that makes sense. And I'm building my
So you're
own
kind of
world.
creating your own. Yeah.
285 lines of code for that whole vision vocabulary.
Nothing to 255. Wow. Yeah, that's pretty lean.
It's not bad.
Priors, blah, the IONM analogy. Oh, can you go to the section 8? Can you click on section 8? I just want to see. Here's the deepest probably to what you do. Another. You monitor, you place selector, you call something. Yeah, knows exactly what I do. Cloud operates the same way in building software. Humans that want to context establishes a baseline. The current, yeah, it's talking my language. Holy shit! Propose interventions. Who looks the approach? Wow, this is actually great when you have it. Because even with the neurophysiology context, it's even more apt for me. Like when you're talking or the IONM, like my specific stuff.
The one thing that is missing from technologists is a complete absence of an understanding of how the brain works, the eye works, the organism works. Does that make sense?
Yeah.
And so we have people who only know how machines work, trying to mimic how the organism works without ever understanding anything about the organism.
And the organism.
Well,
that's the issue I keep hearing about with like health.
Yes.
It's all people that want to do tech and not enough people that know the health part. That's what I'm hoping with the health tech conference. I'm going to the LSI conference next month that my buddy Omar, the health tech guy, he told me about.
Yeah, everywhere I go in AI, everywhere I go in AI, they haven't read any papers on how the eye actually works, how the eye actually organizes information. The eye is not a passive camera. Everyone in AI thinks the eye is a passive camera. Nothing could be further from the truth. Keep reading.
I mean, the eye is an extension of the brain. I don't know if most people realize that. Actually, like embryologically, it is the brain. I mean, the retina is. Yeah, it's all neurons in there. You don't need to understand neurosurgery to IOM. Yeah, you need to understand neurophysiology. Claude doesn't need to understand the business purpose of software to build it. It needs to understand the technical physiology, how signals flow, where latency accumulates, what feedback loops might emerge, when thresholds are crossed. The surprise that surprised you was not built by a large team of months. Built the way you monitor surgery. One human with clear intent, one monitoring system with deep domain knowledge, and a continuous feedback loop between them. Interesting shit, man. Oh, and then is this from the yeah. The script is a monitoring system and has different pathways for continuously at a time. It's built from almost nothing. AI that builds, it operates like you do. You already understand KL divergence. Oh wait, what was the last part of the K? Every time you compare a live SP to the baseline, decide whether the change is significant. You are computing and inform. Oh, yeah, that's true. Shit. Time brain register surprise. That waveform doesn't look right. Your experience is surprise and information theoretic. Yep. That's literally what I do all day. I don't understand, and I understand how this works. Is smaller than you think. The concept is saying only the jargon is different. Oh, an image? Are you doing an image? Yeah. When this recording gets saved, there's going to be a folder in the Google Drive. So it'll get saved on there. I'll put you as like an editor, so you can like, I don't know, do whatever with the video and all that stuff too. Would you be able to, like, these documents, would you be able to paste them in there also? That'd be awesome, actually.
Yeah. Well, I'll
having the record there.
What we're gonna need to get you is a GitHub account.
I have a GitHub, actually. I have one.
You have one. So what I'm going to do, the way we can work together, and this is the way the whole team is working together, is we all publish our GitHubs publicly or privately. And that becomes our context as a service for anything we're working on.
Yeah, I need to figure out how to use GitHub. I still don't fully understand how to use it.
Just think of it as a collective consciousness of folders that are very important. OpenClaw on XRPL, say it ain't so. Imagine AI agents that don't just talk, they pay each other. Real XRP on chain. This is Cindy on the XRP ledger. 18 HD derived wallets from a single mnemonic. 1 persuader, 1 treasury. 16 villain personas. Each villain pays in drops. 1 million per XRP. Before the debate even starts, the server returns HTTP 402 payment required with destination amount and a correlation memo. The client submits a payment transaction. XRPL confirms it in 3 to 5 seconds via submit and wait. Then the debate streams over server sent events. 3 rounds of Cindy versus the villain powered by GPT. When it's over, an LLM evaluates the transcript and scores conversion 0 through 5. If the score is 2 or higher, the Treasury sends a reward transaction back with a memo encoding the score. Lower than 2, no payout. The net result is logged. Every transaction is on the Explorer. It's the X402 protocol. Gate the API, return payment instructions, verify on-chain, then deliver. No checkout flows. No redirects. Network agnostic. We ported this from Stacks. Same logic, different ledger. Settlement in seconds. A market for ideas, where conviction has a price and persuasion has a payout. OpenClaw on XRPL. God. All right, how are we doing over here?
How many tokens do you have total?
Oh, I'm slowly running out. But there's always.
We'll need to. Do you need Gemini tokens if you're going to connect to Gemini to do stuff or whatnot?
Yes.
Because that's where I can come in with my thing.
That's where,
I have tons of tokens. I think it's something I get like 10,000 or 12,000 a month or something like that.
Amazing.
And I'm not using any of it really at the moment. Should try.
So let's see what it does. This is the last piece for today, but let me ask you this for the recording. What the learner learns is a function of what they already know. What did you experience today as if you were talking to a peer neurologist at a conference?
I mean, I think I learned a little better about kind of the underlying architecture of all this, or how, like, in terms of like with like the vision audio stuff. I think it was kind of interesting to see the correlations with like like neurologically how the human body works and how this works. So it doesn't seem as mystifying as to oh, it's how does it know this or that, or how does it know understand the context, or watching, listening, and all that stuff. The whole like inhibition aspect to it, where it'll stop the mic when it's that part we was talking about. I was like, huh, this is interesting. No, it's a little less mystifying. I mean, it's still kind of interesting how it can code so quickly. I don't know how it does that, but I guess that's the easy part, right? I don't know, because it's just I'm still the underlying thing where it's just like it's I don't know. LLMs are still like it's still a bit mystifying in how it just is able to just understand you and I think that especially with the taking the audio and then, well, I guess audio to text, I guess is not that hard to do, and that's been going on for ages. And then because these things work on text and the predictive. That was the other thing that was interesting, was getting that analogy of like the prediction thing, the way that the brain predicts, and then how the AI, because I mean that's what this is all based on, right? Is prediction, knowing probability of like the next likely token outcome, whatever it is. So I think like the underlying fundamentals of this, I think I understand a bit better now. When thinking in terms of probabilities, Kale divergence, all that stuff. No, I don't know. I don't know if that answers the question, but
I don't know why this is taking as long as it is.
you talk to the AI like that?
Yeah.
That's funny.
Hold on.
This is good. Are you going to use the solution now for other stuff? I don't know. Is it useful in other contexts for you? I mean, because this was something that I guess we just, during the course of whatever, that we just decided, hey, this would be something interesting.
Yeah. So, I mean, most podcasts don't result in anything but fucking talking. Now we can actually say, hey, these were the outcomes of this interaction, right? Here's the infographic explaining what happens. Here's the code on how how Brian Claw works, right?
Brian Claw.
Mm-hmm.
Yeah, not Brain Claw, Brian Claw.
Yeah. You can't spell brain without Brian, huh?
Yeah. Very true. I gotta use that next time. Can't spell brain without
My name
Brian.
has AI in it. You sure you want to bet against me? Intelligence artificial.
That'd be a great name for an AI, like an AI company, Brain, but it's like BR, but it's like lowercase b, capital AI.
Yeah.
Lowercase BR, capital AI, lowercase n.
And now you're in Monty Python, The Life of Brian.
Yeah. Maybe that's what I should name, because I have like the whole Bachata bot thing, but like I'm wondering if like whatever the umbrella company for whatever I do or whatnot, maybe I should call it Brain, but call it like BR AI and I don't know.
I like it because it's a funny way to introduce yourself and the thing.
What?
Like the connection between Brian and Brain. Like
Brain,
maybe your whole career was a self-fulfilling prophecy based on.
I think it kind of was. I think this whole I'm almost certain that like, there's a bit of nominative determinism. Yeah, I'm almost positive.
Nominal determinism is amazing.
Yeah. It's nominal. Yeah, what is it again?
Yeah. Real versus nominal. That's
nominative determinism.
Yeah, it's economics. Yeah. Nominal versus real value.
Yeah. Well, this is nominative because this is talking about nominate as in like name, nominative. I think nominal is more with like numerals or something like that.
Nominal
existing in name only, I guess, yeah. Or price. Or I guess nominal
minus inflation equals real is what we learned.
Yeah.
I'm surprised it's taking so long. I wonder if we can have it race. Let's do this.
You see if a human coder could actually code it?
No, I know I'm gonna have the other AI do it.
Oh, Gemini?
No, the cursor has its own.
Oh, its own internal.
Yeah. Where is it? JSON. So that's the other thing too. You know, I'm not just using one AI when I'm building. It's like, look at this. Look how fast I did it. I don't know if it's like bugging out or something, but this is taking 3 minutes. And
How
now
long,
this
should it,
is
how long should it take, you would think?
seconds.
I mean, well, it's...
You got time to waste. People are dying. People are getting dumber because of lack of neurology. We don't have time left. You know how many people we just lost because we don't have a solution?
Wait.
Right? Think about it.
Yeah, well, no, time is brain, as we say.
Yeah, we need full self-driving because these people are running into each other on the fucking highway. That's how I think people are going to look at it, which is, you know what? I know you're smart. I know you've been driving for a while. You may have even won F1. But when it comes to other people's safety,
Yeah.
we actually can't have you drive this car now. It would be a moral and ethical disaster to have you, an even worse stochastic driver, behind the wheel. You know what I mean? All right, so here we go. So while Claude was kind of fucking taking its sweet time, right? Let's see what we have. Ta-da. Now we go from hallucination to mirages, huh?
What's the difference?
Like a hallucination is a spoken mirage, and a mirage is a visualized hallucination.
Visual, yeah. Well, yeah. Okay, yeah. Well, because like hallucination, I think is just a general. I mean, hallucination could is hallucination just done with like audio or with?
I mean, the technically,
Yeah, I mean, a mirage is a visual hallucin. Yeah.
A spoken hallucination in an LLM is kind of likened to the manifestation of the Dunning-Kruger effect. You know, lack of awareness. That's how we would anthropomorphize it. Let's say, right? Not necessarily what's happening under the hood.
Yeah.
But so here's the interesting part now.
It's actually a really good analogy.
Science fair.
Like the neurology and AI thing is actually, it's probably probably the perfect, because everyone always talks about, like, whatever, digital brain, digital, neural networks, whatever, and stuff too. So actually
they talk about it without understanding digital nor the brain.
Well, yeah, I mean, there's that too.